Good morning everyone. In this particular video lecture we will discuss regarding the AC series circuit. Now my dear friends, in this series first of all we will discuss regarding the series RL circuit. Now my dear friends, as you can see here in the particular circuit that there are basically two elements. The first one is resistor and the second one is inductor. Both these two elements are connected in series and the voltage across resistor is VR and the voltage across inductor is VL. And now my dear friends, here we have denoted the overall current by I and the supply voltage is basically V. Now my dear friends, if we write the voltage across resistor, then it will be basically IR, and as we know in case of resistive circuit, the angle between the current and voltage is basically 0 degree, so we write here as IR at angle 0 degree. Now my dear friends, in the same way, if we want to write the voltage across inductor, then that will be basically plus JXL into I. And now my dear friends, as we know, the voltage in case of inductor basically leads the current by 90 degree. So my dear friends, here plus J basically indicate 90 degree in anti-clockwise direction. So here we can write VL means voltage across inductor as XLI at angle 90 degree. And now my dear friends, in this circuit, if we try to find out the overall voltage, then now we can write as minus V plus VR plus voltage across inductor is equal to 0 degree. Now my dear friends, here if you want to calculate the overall voltage, then that will be basically equals to, as you can see here, V is equal to VR plus VL. And now my dear friends, from the above, if we put the value of VR and VL, then that will basically comes out to be V is equal to, if we take common I as the common, then it will basically comes out to be R plus JXL. And now my dear friends, if we send I to the left hand side, then V by I basically will become equals to R plus JXL. Now my dear friends, as we know, V by I means voltage by current is basically equals to resistor, and in this case my dear friends, we will denote it by Z, that is impedance. Now my dear friends, as you now my dear friends, we can write Z is equal to R plus JXL. Now my dear friends, Z is basically here impedance and its unit is basically ohm. And now my dear friends, as you can see here, Z is basically impedance and its unit is ohm, and Z is equal to R plus JXL. And my dear friends, if you want to basically calculate the magnitude of Z, then that will basically comes out to be root under R square plus XL square. Now my dear friends, we will now try to draw the basically phasor diagram for the series RL circuit. Now my dear friends, if we talk regarding the series circuit, then in series circuit basically the value of I is common. So here for drawing phasor diagram, we will take basically I as odd difference, and accordingly we basically draw the phasor diagram. Now my dear friends, this is basically I, and in case of resistor, the voltage is basically in phase with I. So here we have denoted the current I and voltage across resistor in the same phase. And now my dear friends, as we know that the voltage in case of inductor basically leads the current by 90 degree, so this is basically current and this is basically the we can say the 90 degree leading voltage across the inductor. Now my dear friends, if we want to calculate the equivalent, then we will join this point, and my dear friends, this will basically comes out to be equivalent voltage, that is V. And now my dear friends, as you can see here, this is basically the voltage across resistor, and this is basically the voltage across inductor, and my dear friends, this is basically the current which we have taken as a reference in this circuit. And now my dear friends, as we will join these 2 points to get the equivalent voltage, then that will be basically equals to I into Z, where I is basically current and Z is basically the impedance. And now my dear friends, we can also say here that basically, as you can see here, this is basically the overall voltage and this is basically the overall current. So my dear friends, as you can see here the voltage is leading by current by the angle less than 90 degree, as you can see here. And in the second way, or we can say in the other way, that I means current lag V by angle phi, which is less than 90 degree. Now my dear friends, as we will proceed further, then we can say here V is equal to VR plus JVL, and if we want to find out the magnitude of V, then that will be basically comes out to be root under VR chi square plus VL chi square. Now my dear friends, in this triangle, if you want to calculate the value of tan phi, then as you can see here, it will basically VL by VR. Now my dear friends, as you can see here, the value of tan phi is equal to VL by VR, and if you want to calculate the value of phi from here, then that will be basically comes out to be tan inverse VL by VR. Now my dear friends, if you want to calculate the value of basically if you want to calculate the value of cos phi from here, then that will basically comes out to be VR by V, we can say. And my dear friends, if you want to calculate the value of VR, then that will be basically comes out to be V into cos phi. Now my dear friends, this was all about the basically phasor diagram of we can say the series RL circuit. Now my dear friends, if you want to calculate the as we know that the value of cos phi is basically equals to the power factor. So my dear friends, here in this case, if you want to calculate the value of cos phi from here, then that will be basically comes out to be VR by V, as you can see here, VR by V, and this is basically the value of power factor. Now my dear friends, if you want to calculate the value of sin phi from the given phasor diagram, then that will be basically comes out to be VL by V, and if you want to calculate the value of VL, then that will basically comes out to be V sin phi. Now my dear friends, here as you can see here, the overall voltage is basically we can say the overall voltage is basically we can say is leading with the current by the angle phi, which is less than 90 degree. So my dear friends, in this case we can say that the voltage is basically lagging, the power factor will be basically lagging in nature. Now my dear friends, as we move to the next one, that is we will basically draw the impedance triangle for the series RL circuit. Now my dear friends, as you can see here, this is basically, as we know, on the reference we basically VR is on the reference, and VR is equal to, as we know, I into R. So if we take R from here, and in case of inductor, basically this was basically VL, and VL is basically, as we know, plus J I into XL. So we will take XL from here. Now my dear friends, if we draw the triangle with the combination of both these resistor and this we can say my dear friends XL, then that will basically comes out to be impedance triangle, and this will be basically the equivalent Z which will basically equal to R plus, my dear friends, JXL. Now my dear friends, as you can see here, Z is equal to R plus JXL, and if you want to calculate the magnitude of Z, then that will basically comes out to be root under R square plus XL square. Now my dear friends, if you want to calculate the value of tan phi, then as you can see here from this figure, that tan phi will be equals to basically XL by R. And my dear friends, if you want to calculate the value of phi, then that will be equals to, as you can see here, tan inverse XL by R. And my dear friends, if you want to calculate the cos phi, that is the power factor, then that will basically comes out to be we can say R by Z. And my dear friends, if you want to calculate the value of R, then that will be equals to Z into cos phi. And if you want to calculate the value of sin phi from here, then my dear friends, it will basically comes out to be XL by Z. And my dear friends, as you can see here, the value of sin phi is equals to XL by Z. And if you want to calculate the value of XL from here, then that will basically comes out to be Z into sin phi. Now my dear friends, we will basically draw the power triangle for the series RL circuit. Now my dear friends, as you can see here, basically as we know the value of impedance, that is Z is equal to R plus JXL. And now my dear friends, as we know the value of power is equal to V into I and I square R. Now my dear friends, if we basically multiply this whole equation by I square, then as you can see here, this will basically I square Z is equal to I square R plus J I square XL. Now my dear friends, in the impedance triangle, we have seen that this was basically R, and this was basically XL, and this was basically Z. Now my dear friends, if you multiply basically this by R square, and if you multiply the R by R square, and this will basically multiply by R square, then as you can see here, this was basically equals to S here. This was basically equal to S. I square Z was basically equal to S, and my dear friends, this was basically equal to P, and this is basically equal to QL. Now my dear friends, as you can see here in this derivation, that S is equal to P plus JQL. Now my dear friends, we also know that V is equal to VR plus JVL. Now if you multiply the both side by I, then that will be basically equals to S plus S is equal to P plus JQL. Now my dear friends, if you want to calculate the magnitude of S, then that will basically comes out to be root under P square plus QL square. Now my dear friends, if you want to calculate the value of tan phi from this triangle, then it will basically comes out to be QL by P. Now my dear friends, as you can see here, basically QL by P, if you want to calculate the value of phi from here, then that will basically comes out to be tan inverse QL by P. And now my dear friends, similarly, if you want to calculate the value of cos phi, that is power factor, then this will basically comes out to be P by S. And now my dear friends, if you want to calculate the value of P from here, then that will basically equals to S into cos phi. And my dear friends, as we know, S is equal to V into I. S is equal to V into I. From here, as you can see, S is equal to as you can see here, S is equal to V into I. So here we have put the value of S, and that will basically comes out to be Vi cos phi. And now my dear friends, if you want to calculate the value of sin phi from here, then that will basically comes out to be QL by S. And if you want to calculate the value of QL from here, then that will basically comes out to be S into sin phi. And now my dear friends, as we already know that S is equal to V into I, so here the overall value of QL will comes out to be Vi sin phi. Now my dear friends, the next one is, that is, as you can see here, S is equal to P plus JQL. This was basically my equation. And my dear friends, S is equal to P plus JQL. Now my dear friends, we will basically know we call P as active power or true power, and its unit will be watt. Now my dear friends, we call QL, this one QL, we call QL as reactive power or wattless we can say, and its unit will be kVAR. Now my dear friends, we call S as apparent power. We call S as apparent power, and it will be measured in basically VA, volt ampere. Now my dear friends, this was basically the power triangle, as you can see here. Now my dear friends, the next one is basically RC circuit. Now my dear friends, we have basically talked regarding the phasor diagram, impedance triangle, power triangle of the series RL circuit. And the next one is basically series RC circuit. Now my dear friends, as you can see here, this is basically a circuit containing a resistor R and a capacitor C as element. Now my dear friends, the voltage across the resistor R is VR and the voltage across capacitor C is VC. Now my dear friends, as you can see here, as we know, VR is equal to IR, and we can say it as a IR at angle 0 degree. And now my dear friends, we can say VC is equal to minus J XC into I, or we can say XCI at angle minus 90 degree. Now my dear friends, as we know, angle measured in anti-clockwise direction is taken as positive, and angle measured in clockwise direction is taken as negative. So my dear friends, as you all know that the voltage, if you draw the phasor diagram, then this will be basically current, and this one is basically will be voltage in case of capacitor. Now my dear friends, as you can see here, the voltage is basically 90 degree clockwise to the current. So my dear friends, here we are using negative sign in the value of voltage. Now my dear friends, basically the negative sign is showing that the voltage is basically lagging the current by 90 degree. So my dear friends, this was all regarding the circuit. And now my dear friends, in this circuit, if you want to calculate the equivalent voltage, then that will basically comes out to be V is equal to VR plus VC. Now my dear friends, here we will basically put all the value, and as we put all the value, then we will basically get V is equal to I into R minus JXC. And if we send the I to the left side, then we will basically, then the equation will basically comes out to be V by I is equal to R minus JXC. And now my dear friends, we will basically denote V by I, as we know V by I is equal to R, which is basically resistance. Now my dear friends, in this case we will basically denote it by Z, which is basically impedance, and the value of impedance will be comes out to be R minus JXC in case of series RC circuit. Now my dear friends, this was all about the basically calculation of voltage. Now here we will basically draw the phasor diagram. My dear friends, one point here to be noted is that in case of series RL circuit, the value of basically impedance was comes out to be R plus, we can say, JXL. And now my dear friends, in this case, in case of series RC circuit, the value of impedance is comes out to be R minus JXC. This point is very much important, so we should have to keep it in your mind. Now my dear friends, first of all we will draw the phasor diagram. My dear friends, as we know, in case of series circuit, in case of element when connected in series, the value of current is common in both the element, or we can say the all number of elements, the value of current is common. So my dear friends, here we will take current, that is I as a reference, and after taking I as a reference, we will basically draw the voltage through the resistor. So my dear friends, the voltage through resistor will be denoted by VR, as you can see here. So this one is basically current and this one is basically voltage across resistor. Now my dear friends, as we know, the voltage across capacitor is denoted by VC, and we also know that the voltage across capacitor basically lags to the 90 degree to the current, lags at 90 degree to the respective current. So my dear friend, this is basically current, and the voltage across capacitor will basically lag 90 degree. So my dear friends, this is basically the voltage across capacitor. If we, my dear friends, if we draw the equivalent voltage, then this will be basically comes out to be equivalent voltage. Now my dear friends, this is basically equivalent voltage and this is basically equivalent current. And now you can see here the voltage in case of basically series RC circuit is lagging to the current by 5, which is basically we can say less than 90 degree. So my dear friends, we can see say that the in case of series RC circuit, the current I will basically lead the voltage by angle 5, which is basically less than 90 degree, as you can see here. Now my dear friends, as we move on the next thing, that is, as we know, V is equal to, means voltage is equal to, as we know, V means voltage is equal to VR minus JVC, my dear friends. So if you want to calculate the value of voltage from here, then that will basically comes out to be root under VR k square plus VC k square. Now my dear friends, if you want to calculate the value of tan phi, then that will be basically comes out to be VR by VC by VR. And now my dear friends, if you want to calculate the value of phi from here, then that will basically comes out to be phi is equal to tan inverse VC by VR. Now my dear friends, the next thing which we will calculate is basically the power factor, that is cos phi. And now my dear friends, from this phasor diagram, or you can say the triangle, if you want to calculate the value of cos phi, then that will basically comes out to be VR by V, as you can see here. So my dear friends, the value of power factor, that will be cos phi is equal to VR by V. And if you want to calculate the value of VR, then that will basically comes out to be V into cos phi. Now my dear friends, if you want to calculate the value of sin phi, then that will basically comes out to be VC by V. Now my dear friends, VC by V. And if you want to calculate the value of VC, then that will be basically comes out to be V into sin phi, as you can see here. Now the next thing we will discuss regarding series RC circuit is impedance triangle. Now my dear friends, as you can see here, here we have drawn the impedance triangle. First of all, we will talk how we have drawn this triangle. My dear friends, as you can in the phasor diagram, you have seen that this was basically the VR, and this was basically we can say the voltage across capacitor. Now my dear friends, if you want to calculate the voltage across we can say resistor, then that will basically comes out to be I into R. So my dear friends, in impedance triangle we basically considered R. So here we have noted it as R. And in case of, my dear friends, if you want to calculate the voltage across capacitor, then that will basically comes out to be minus J, my dear friends, into XC into I. Now my dear friends, in case of impedance triangle, we will basically consider XC from here. So my dear friends, here we have noted it as XC, as you can see here. Noted XC, as you can see here. Now my dear friends, if we want to calculate the basically equivalent impedance, then we have to basically join this point, and after joining, this will be basically the Z, that is impedance. Now my dear friends, as you can see here, Z is equal to R minus JXC, and if you want to calculate the value of Z, then that will basically comes out to be root under R square plus XC square. And now my dear friends, if you want to calculate the value of tan phi, then that will basically comes out to be xc by r. And if you want to calculate the value of phi, then that will basically comes out to be tan inverse xc by r. Now my dear friends, if you want to calculate the value of power factor, that is cos phi, from this triangle, then it will basically comes out to be r by z. And now my dear friends, the same, if you want to calculate the value of r from here, then that will basically comes out to be z into cos phi. Now my dear friends, if you want to calculate the value of sin phi from this triangle, then it will basically comes out to be xc by z. And if you want to calculate the value of xc, then it will be z into sin phi. Now my dear friends, this was all about impedance triangle. The next we will discuss regarding the power triangle. Now my dear friends, as we know that as you can see here, the value of as we know, the value of amount of power is basically equals to P is equal to I square R or V into I. Now my dear friends, in case of series RC circuit, the value of equivalent volt, we can say equivalent impedance, is equal to R minus JXC. Now my dear friends, in the whole equation, if you multiply by I square, then as you can see here, I square Z is equal to I square R minus JI square XC. Now my dear friends, we have given the name I square Z as S, and we have denoted I square R as P, and we have denoted minus J. Now my dear friends, the next one, we have denoted I square XC as QC. As you can see here, this is basically apparent power, this is basically active power, and this is basically reactive power. Now my dear friends, in the impedance triangle, we have drawn this as R, and this as we can say XC, and this was basically Z. If we want to if we multiply all these things by I square, then as you can see here, this is basically I square by R, or we can denote it using P. Okay my dear friends, and if you multiply this by I square, then we can denote it by QC, my dear friends. Now my dear friends, as you can see here, this was all regarding the active, reactive, and we can say apparent power. Now my dear friends, as we move to the next thing, that is as you can see here, my dear friends, that is, if you want to calculate the value of S from here, that is apparent power, then that will basically comes out to be root under P square plus QCK square. Now my dear friends, if you want to calculate the value of tan phi from the given power triangle, then it will basically comes out to be QC by P. And if you want to calculate the value of phi from here, then that will basically tan inverse QC by P. Now my dear friends, if you want to calculate the value of power factor from this given triangle, then that will basically comes out to be P by S, my dear friends. And now my dear friends, this is basically, if you want to calculate the value of we can say power factor, then as you can say here, P by S. And if you want to calculate the value of P, then that will basically comes out to be S into cos phi. Similarly, my dear friends, we will derive all these formula from this given power triangle. Now my dear friends, as you can see here, this is basically the equivalent power triangle in the case of we can say series RC circuit. Now my dear friends, we will discuss basically numerical based on series we can say RC circuit. Now my dear friends, as you can see here in the given question, that series RC circuit have a supply voltage 5 volt. We can say the supply voltage is given as 5 volt, and voltage drop across resistor is given at 3 volt, my dear friends. Then we have to basically find out the voltage across capacitor, and we have to basically find out the power factor. Now my dear friends, first of all, we will basically draw the, we can say, the phasor diagram of series RC circuit. Now my dear friends, for drawing phasor diagram of series RC circuit, as we know, we take current as a reference, and then we basically draw the we can say the voltage voltage across this is basically the voltage across capacitor, this is basically the voltage across, we can say, resistor, and this is basically the equivalent voltage. Same in the here, basically, my dear friends, the value of VR is given as 3 volt, and the overall voltage is given as 5 volt. Now my dear friends, from this by using Pythagoras theorem, we can calculate the voltage across capacitor, and that will basically comes out to be, we can say, 4 volt. As you can see here, this is basically comes out to be, my dear friends, 4 volt. Now my dear friends, as you can see here, basically we have to calculate the value of power factor, that is cos phi. Now my dear friends, first of all, we will calculate base now my dear friends, as you can see here, as we know the from this basically phasor diagram, my dear friends, we can easily calculate the value of we can say, my dear friends, power factor, that is cos phi, and cos phi, that will be equal to 3 by 5, we can say, and that will basically comes out to be 0.6. My dear friends, as we know, in case of series RC circuit, the overall we can say the circuit is leading in nature because due to the presence of capacitor. And now my dear friends, the second way is basically to calculate this is basically the first way to calculate the power factor, and my dear friends, this is basically the second way to calculate the power factor. Now my dear friends, as we know, the series RL circuit is basically lagging in nature, and the series RC circuit is basically leading in nature. And the leading nature of the series RC circuit is due to the presence of capacitor in this circuit, and my dear friends, the lagging nature of this circuit is due to the presence of we can say inductor in this circuit. Now my dear friends, this was all about the basically series RC circuit and RL circuit, in which we have discussed regarding the phasor diagram, impedance triangle, and we can say power triangle, and then we have discussed the numerical, my dear friends. Now my dear friends, in the next video we will basically discuss regarding the, we can say, the series RLC circuit, and then we basically discuss the, we can say, the series we can say resonance. Now my dear friends, this was all regarding the, we can say, series AC circuit. I hope you have enjoyed this video. That's all. Thank you.